All right, today we're going to be talking about polygons and angles. So you can use the angle measures of a triangle to find the sum of an interior angle measures of these different polygons. So let's start by looking at the triangle. We know the triangle has three sides. How many triangles are there? There's one, and we just did in our past unit that the sum of these angle measures are 180 degrees. Next one, we're looking at a quadrilateral. There are four sides. When we're talking about the number of triangles, if I start from a vertex and I draw my lines, well, this is the exterior side. If I connect it to the next vertex here and to the next one here, that's the outside line again, there's 1, 2 triangles. Well, if one triangle is 180 degrees, two triangles would be 360 degrees. All right, now we're on a pentagon. 1, 2, 3, 4, 5 sides. Again, if I start from one of my vertices and I connect to the other ones, that's the exterior, connect to this one, connect to this one. If I connect here, that's our exterior. So now we have 1, 2, 3 triangles. So if one is 180, three triangles is 540 degrees. And then here we've got 1, 2, 3, 4, 5, 6, a hexagon. I'm going to start at one of my vertices and connect. Exterior, inside, 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 exterior. We have 1, 2, 3, 4 triangles, which if one triangle is 180, four triangles are 720 degrees. Okay, so if we're looking at this, if you make an observation, what equation can be used to find the sum of the interior angles? So we're looking at the sum of the interior angles of a polygon with an unknown n number of sides. Well, if we look at this, 3 sides minus 2 is one triangle. 4 sides minus 2 is 2 triangles. 5 sides minus 2 is 3 triangles. 6 sides minus 2 is 4 triangles. So if we take the number of sides and we subtract 2, that tells us the number of triangles. So that's part of it. N minus 2. This number of sides minus 2 will tell us how many triangles are in there. And then we know each triangle is 180 degrees. So it's 180 times that value. So now we're going to use that to find the measures of the interior angles of each polygon. So we are specifically looking for the sum of the interior angles. A nonagon has 9 sides, so we're just going to plug this into our formula. 180 times 9 minus 2. So 180 times 7 equals 1,260. For an octagon, octagon has 8 sides, so we're going to plug that in. 180 times 8 minus 2. So 180 times 6 equals 1,080. And a 15gon. So some of our polygons have specific names. Once we get to some of these higher values, they don't necessarily have specific names, so we just call them whatever number of sides, gon. So 15gon has 15 sides. So 180 times 15 minus 2. So 180 times 13 equals 2,340. So when you have a regular polygon, is a polygon where all sides and angles are congruent. So, when we think of hexagon, we normally think of our regular hexagon. This is not a regular hexagon. The side lengths are different, the angle lengths are different. But When we have a regular polygon with them all equal, we can use this formula to then figure out what one of the angle measures would be. So write an equation that can be used to find the measure of one interior angle of a regular polygon with n sides. So we already know that the sum is 180 times n minus 2. So now we want to know what one of the interior angles is. So if there's n sides, that means there's n angles. So we're going to take our sum and we're going to divide it by the number of angles, or the number of sides. So find the measure of one interior angle of each regular polygon. So make sure you're just paying close attention to what it's asking for. Heptagon has 7 sides. So we're going to do 180 times 7 minus 2 to figure out what our entire sum is. So 180 times 5 equals 900. Then we are going to divide it by the number of sides and angles, divided by 7. We get about 128 and 6/10. That's rounded. So about 128 and 6/10 degrees. Make sure to put that degree symbol. All right, octagon has 8 sides. So we're going to do 180 times 8 minus 2. 180 times 6 equals 1080. Divide by 8 angles and sides equals 135 degrees. For a 20 gun, it's 20 sides, 180 times 20 minus 2. So 180 times 18 equals 3,240 divided by 20 sides and angles equals 162 degrees. So one thing I want you to look at, just making observations. We had a 7, then an 8, then a 20. And if you notice, as you get bigger polygons, our interior angle measures are getting bigger. And think about our smallest polygon is a triangle. That interior angle is 60 degrees. So the bigger the polygon, the bigger the interior angle is going to be. Exterior angles, the angle between any side of a shape and a line extended from the next side. So we have our interior angles, now we're looking at the exterior angles. We're not looking at the entire outside, right? We're not looking at this entire reflex angle. We are just looking at when we kind of extend lines from it, what it would look like. So what we were going to do is use some protractors to figure out the angle measures here, but I don't have a protractor with me, so we're just going to kind of make some observations here. If we think about it as a triangle, okay, we know if we have a straight line here, that straight line is 180 degrees. Okay, so here, if this interior angle is 30 degrees, this exterior angle here is 150 degrees. So we're just talking about extending the line and just measuring it right here. So if we were to do it here, it would be, okay, we're going to extend this and measure this angle. We're going to extend this, measure that angle. Extend this, measure that angle. Extend this, measure this angle. Extend that, measure this angle. Extend this, measure that angle. So those are the angle measures that we are talking about there. What we should have done if we were doing this in class and found we would be making some observations, we would have found that the sum of the exterior angles is 360 degrees, no matter what. So no matter what shape we are looking at, the sum of those exterior angles should be 360 degrees. So knowing that, let's find the measure of an exterior angle of each regular polygon. So when we're looking at this, we're saying it's a regular polygon. So that means all angles are congruent on the inside, which means all angles are congruent on the outside. So we're just going to take our 360 degrees and we're going to divide it by the number of sides. So 360 divided by 3 equals 120 degrees, which makes sense because if we think about a triangle, if you have an equivalent triangle, it's 60-degree angles. 60 plus 120 is 180 for the exterior angle. Pentagon, our 5-sided figure, we're taking 360 degrees, dividing it by 5. 360 divided by 5 is 72 degrees. Octagon has 8 sides. 360 divided by 8 is 45 degrees. So again, if you're making observations here, we went from 3, 5 to 8. As we got bigger in number of sides, our exterior angles got smaller, which makes sense because we're taking the same number and just dividing it by a bigger number. All right, go ahead and work on the attached homework.